I'm Chris Bragg, Head of Programming here at the Laidlaw Music Centre, and tomorrow we have a very special concert here at lunchtime. It's called Intersections, and the point about this concert is that it's entirely made up of new music, music that nobody has ever heard before. And this music has been composed by composition students at the Royal Conservatoire of Scotland who've been working in collaboration with researchers, doctoral researchers here at the University of St Andrews to create new pieces of music about their research, about subjects that normally music isn't composed about. So, for instance, we're going to hear a piece tomorrow which is all about medical care at sea during the Napoleonic Wars, and we're going to be hearing music about the formation of stars. And what's really exciting for us is that this music is going to be performed by our own scholarship holders, and they're going to be performing in duos. You'll hear stringed instruments, brass instruments, wind instruments, one of our wonderful singers performing with one of our piano scholars. Now, you can join us in person tomorrow if you like, right here in the room. Just go to the Buyer Box office to reserve your place. Otherwise, you can join us on YouTube, on the Music from St Andrews YouTube channel, or indeed on our Facebook platform at 1:10 Otherwise, if you don't have time tomorrow, it will be sitting there on our YouTube channel and you can watch it at your own convenience. So, we hope that you, like us, are looking forward to this special concert of very, very special music which nobody has ever heard before.
Hi, I'm Thorsten. I'm a PhD student here at the University of St Andrews, and I'm doing my PhD in astrophysics. In particular, in my PhD, I take a look at objects that are called protoplanetary disks, and as the name might suggest, protoplanetary disks are the object where planets ultimately form. To give a bit more broader context, protoplanetary disks are a phase that stars go through in their whole birth process called star formation. In the piece that you will hear, we try to take you on a journey through this whole step of, or this whole process of star formation, and try to illustrate this process with the help of music. I'm really glad that I could take part in this because it's always a very particular problem. How can you translate the science that you do every day? How can you make the boring plots, the boring figures interesting to people who are not part of the field? And I think music in particular can be a very good tool to illustrate how beautiful and rich the science is that we're doing from day to day. I'm really glad that I was chosen, or that my topic was chosen, and was really happy to work with Siobhan on this, because I immediately felt like that the science that I'm working on was falling on fertile ground, so to say, because she seemed very interesting in the field, very interested in the topic, and I felt we worked seamlessly with each other in creating this piece that you might hear.
Me and Thor started working together as a matter of kind of almost chance, but not quite. I've really enjoyed working with him, and I hope that we get to do something together in the future because we became pretty good friends. With the piece, I wanted to incorporate his research into the formation of stars and whether or not lightning exists in dusts in space. I found it very interesting and wanted to try and find something that would kind of incorporate that. I tried to go with the circular shape of like stars and planets and all that. And I did incorporate some of the circular shapes. I also wanted to follow the pattern of one of the space clouds, and I have incorporated that into my piece as well.
One very interesting aspect on how we came up with the whole process is, with the whole piece, is that star formation tends to take place in objects that are called filaments, which are very elongated structures, and they leave a very particular mark in the sky that astronomers tend to investigate. And that's why we also chose the name for our piece, Birthmark, because these are the birthmarks of star formation. And in the field of planet formation, you have actually a very similar analogy that in order for planets to form, you have to mix up a bunch of material. And this tends to happen in something that are called streaming instabilities. And these streaming instabilities have very, very similar looking features. They to some degree look similar to the filaments, even though the physics is way, way different, and we talk about different orders of magnitude. But the resemblance of the two birthing processes of the actual birth of a star and the birth of a planet is always a bit like poetry. It seems to rhyme. And that always fascinated me. And I feel, especially with music, with musical motifs, with musical interpretations, you can create these poetic, this rhyming very, very nicely in them. I feel that with what Siobhan created, she definitely nailed that, and I really hope that you see this as well and share now the fascination that I have with the topic.
It's called Birthmark because there's this one particular cloud in space that looks like it's been marked on purpose. It's a giant scratch. I can't quite remember the name of it, but yeah, I hope you enjoy.
My research explores how naval surgeons in the British Royal Navy participated in medical and scientific debates during the French Revolutionary and Napoleonic Wars. The final decade of the 18th century leading into the 19th century was a key moment in the development of modern clinical medicine in Europe. Understanding how naval surgeons contributed to these developments, drawing on their experiences in global spaces, is at the heart of my research. Using patient cases that naval surgeons recorded in journals on board ship, I examine how these surgeons employed different medical theories to understand disease, how it emerges and spreads. I also explore how surgeons participated in medical science through early clinical trials and circulated their findings with their peers.
The setting and environment that this research emanates from is just so exciting. The ship being the center of where it all happens, out at sea, with lightning strikes, poisonous animals, diseases of all kinds, from scurvy to yellow fever. And then, in the middle of that, the surgeon documenting the experiences. Not only do we get to see how life could be for these people, we also get an insight in such formative years for the history of modern medicine. So, when reading Manon's proposal, I knew right away that I wanted to portray this.
My collaboration with Gabriel explores one facet of this research, the surgeon's continuous and sometimes fruitless efforts to provide medical care in the small, cramped space of a ship during thunderstorms, battle, and the heat of the tropics and the cold damp of the North Atlantic.
As Manon's research much revolves around the surgeon's journals, I knew I wanted that to make up a big part of what the composition should consist of. I am very interested in musical metaphor, and have earlier written an orchestral piece based on poems of my own. There I transcribed recordings of the poems that then became the musical building stones of the piece. I also got introduced to a song by John Coltrane on his album from 1965, A Love Supreme. The song is called A Love Supreme Psalm, and is basically Coltrane in real time transforming the words from a poem or prayer that he wrote into notes. When you listen, you can hear the words through the notes, even though the words are never spoken. I wanted to achieve the same thing here, but with the words from the surgeon's journals. So me and Manon selected a few quotes from the journals that I then composed melodies for. The words are there, but they are never spoken, not in a conventional way at least. For me, that has been a way of getting as close as possible to the research while writing this piece. The actual words of the surgeon are echoing through the soprano saxophone.
Gabriel has done a fantastic job conveying these themes of my research, especially the trial and error involved in treating patients with a limited understanding of disease etiology. The often chaotic tensions between different medical theories is also audible in this composition.
I very much enjoyed being invited into another academic world, where I usually have very little insight. And Manon's way of describing her research is so passionate, and it's really got me to understand and appreciate the significance of her work. It is such an honor to get an opportunity like this. To be able to tell a story like this, you need the right background information, and I just don't think that it would have been possible without talking with someone who's both so well acquainted and engaged in the topic.
I was initially interested in participating in this program because it offered such a clear opportunity to communicate my research to a broader audience. But I was also curious about the process. How can you convey these abstract ideas into music? Working on this collaboration has been such a pleasure, as Gabriel listened to my ramblings and plucked out ideas that he could then flesh out through his composition. As a researcher, it was really informative to see what he picked up on, what he thought was most interesting or intriguing. It helped me understand my own role as a historian, how I might better engage with the public and audience, capture their attention, and explain my research more effectively. I really hope you enjoy the composition that has emerged from this collaboration. Thank you.
Over the past number of years, I've been struck by, I guess, both the beauty and the emotional content of some of the work that I do, and I've been searching for different ways to communicate that, both to different audiences as well as different ways to engage with that knowledge, and so I was really excited to be able to take part in Intersections.
I think for me, what interested me about this research was almost the broadness of the topic and the fact that it was something to me as someone who isn't involved in science, almost quite like an abstract subject. These ideas of development and transformation and continuous evolution, and the way that these are changing over time or staying the same or dying out. A lot of my practice as well tends to be involved with just considering time. And so then I felt that focusing on organisms and their complex mosaics of diversity was an interesting way to consider time as a whole.
I'm a macroecologist. I'm studying biodiversity change across the planet with a special interest on coral reefs. When I do field work, that's what I do. I go diving in beautiful reefs. And I guess in also not so beautiful reefs, as reefs have been undergoing some of my study sites have been undergoing some pretty dramatic changes in the recent past.
This idea of constant change and development is a very large part of her research, as I mentioned. But when we began to discuss this more, I felt that it would be really nice for the piece to be exploring that on a personal level. And so I had like a few plans on how I was going to go about this, and one of them was going to be creating work that was developing itself continuously, that you could like check in with any point and it would be completely different every time. But then I started thinking of this idea more of someone or something, like not necessarily a human existence, but some kind of living being, considering all of this hope and death and change that happens over time, and perceiving that in a flat way and feeling like, oh, okay, this is the past, this is the present, this is the future, and being able to experience all of that simultaneously.
It's also been really interesting to see the different ways in which I guess musicians and scientists look at the same knowledge, the same information. And I've actually been struck by how much language we share. I was a little bit concerned that language would be a barrier. Sometimes, my fault in there, sometimes scientists are stuck with sort of too much jargon and it's hard to communicate. But Zio very quickly extracted, I guess, the essence of my research in really interesting ways.
Working with this research has definitely inspired me to find out more about biodiversity. I also feel a strong attachment now to this coral reef in particular that Maria was showing in her studies. And I really want to check in with it in a few years and see how it's doing, if it's continuing to thrive. There's also something to me about Maria's research that was very humbling, because life and death are so close to each other. And there's such hope in that, but there's also a realism that anything that is present right now could go at any second. And I really wanted to hold on to that and bring that into the work, but also it's just something I would love to explore more.
It's good to understand how the creative part of what we do is actually not that different, probably, between science and art. And again, the ways in which we ended up thinking about communicating the knowledge. Although I'm sure Zia was thinking in notes and I was thinking in code, they were not that different, and that's that's a really interesting thing to find out. We have more in common than I appreciated before engaging with this, and I look forward to doing more of that in the future. So and I hope people like the music as well. Thank you.
I was really keen to get involved in Intersections this year. I really enjoyed last year's pieces. I love music in general, and I was really curious about this challenge of communicating academic research through music. I thought it would be really difficult to translate my research into musical concepts, but Ellie was full of great ideas from the start, and it was fascinating to get an insight into her process as a composer.
I knew I wanted to work with Matthew when I realized we had the shared philosophy that art is an excellent medium for sharing ideas. And as a composer, it's really important to me to write music that is both inspired by and directed towards the world around me.
Ellie asked me at the beginning of our collaboration, what would you like the audience to take away from this? And I thought that was a really great question for anyone to use as a starting point, whether it's for preparing a talk for a conference, writing an academic paper, or as it turns out, composing a piece of music. So my research is on New Caledonian crows and the tools they use for foraging. These are birds endemic to the islands of New Caledonia in the South Pacific, and they're famous for making and using a few different types of tools to extract invertebrates as their prey from holes in trees and other places they can't quite reach with their bills. One tool type that I've been particularly interested in we call a hooked stick tool, which is, as the name suggests, a stick with a small hook at one end.
Admittedly, biology has not been my strongest subject, but I found while working with Matthew that his research ended up being a lot more accessible and relevant than I had initially anticipated.
We know that crows make these hooked stick tools from a number of different plant species, which is interesting because it raises the question of whether some plants are better than others for making these tools. But it's actually really difficult for us to identify which plant species tools are made from in the first place. That's because it's very difficult to observe the birds making tools in the wild, and also the amount of processing that goes into manufacturing the tool means that the final tool looks very different to the plant that it originally came from. But we recently had a bit of a breakthrough on this front using a technique called DNA barcoding, which involves taking a small sample of DNA from your unknown crow tool and comparing this to a database of plant DNA sequences and looking for a match.
One way that Matthew and I decided to apply his research to the music was to map the nucleotides of plant species that he identified through DNA barcoding to the notes played by the violin and cello. This ended up working quite beautifully on the open strings of both instruments, because the nucleotides, the 4 nucleotides, are abbreviated with the letters A, T, C, and G. And by replacing the T with a D, almost all of the notes were able to be played by the open strings on the violin and cello. Another way that we integrated his research with the music was to use the idea of the hooks that the crows build with their beaks into the glissando shape played by the violin and the cello, particularly towards the end of the piece. As the piece progresses, this glissando gets increasingly higher in pitch, and this demonstrates the progressive construction that the bird is making of the hook into the usable tool. I also like the more abstract idea that our understanding of the world around us is an ever increasing curve, and how through little steps, like Matthew's research, we are ever understanding more. And I had a really good time working with Matthew, and I'm grateful for this learning opportunity. I'd like to thank the performers for their excellent efforts, Matthew for helping me with this project, and Barry for making this all possible. I hope you enjoy.
I think it's a really beautiful concept to for her to have extracted music from the DNA of these tools. It was a pleasure working with Ellie on this project. I'd like to thank her for all her hard work. Thanks to the musicians as well, and to Intersections for giving us this opportunity to collaborate.
A few months ago, I heard about an opportunity to work with a composer at the Royal Conservatoire in Glasgow to create a piece of music based on my PhD project. I jumped at the chance to do this because I think it's really important for research to be shared more broadly than solely through academic channels, and communicated to a wider and more diverse audience. And I can't imagine a more engaging and creative way of doing this than through music.
The reason why I choose Anna's research is because I explore different aspects of climate change and of the Anthropocene within my music as a way to rethink ideas of nature and of ecology. Anna's research is based on the Aquahal ecology and negotiates both the ecological as well as the sociopolitical and legal effects of harvesting the Aquahales. For people wondering what the Aquahales are specific palm trees that we can find in the Peruvian Amazon rainforest.
My research is taking an interdisciplinary approach, using the natural and social science methods to try to understand, firstly, how the social, legal and political regulations and structures in Peru influence the harvesting practices of rural communities, and secondly, how these harvesting practices and methods of obtaining the aguaje fruits physically and ecologically impact the peatlands in the Pastaza-Marañón Fallen Basin. It's important to understand this relationship from both ecological and social perspectives so that regional and national decision makers in Peru can ensure that the peatlands are protected from harm, while simultaneously allowing the rural communities who live near them to access the natural resources that they need, and to enable the decision makers and the government to plan exactly how to manage this complex dynamic relationship to ensure that both the communities and the ecologically important peatlands continue to thrive in future.
The way we collaborated with Anna is that she sent me lots of data, both ecological and sociopolitical, she collected when she visited that region. She also sent me interviews she had with locals and some field recordings. I tried to analyze and understand all the data she sent me, and I ended up with an ecological data chart that shows the effects of the two different natural resource harvesting activities. The one is by climbing the trees, and the other one is by cutting the trees down in order to get the fruits. What was really interesting about analyzing this chart is that each harvesting activity developed different pathways of effects, that in some cases some effects were overlapping other effects and pathways, and thus some natural loops and natural overlaps were also created. And in the end, a natural cycle could be seen that was repeating itself. What I did is that I tried to translate each pathway as a musical phrase, and I structured the piece based on the chart and, of course, the pathways that were created. So the piece, in the end, becomes a root game or a pathway game piece that the performers, as a duo, need to decide the way they're going to harvest the aguajales, and then they need to decide the pathway of effects of the way they choose. In order to complete the piece, they need to explore different pathways and explore different effects and both harvesting activities. That's all. Thanks for listening. I hope you enjoy my piece, and thank you.
It's been really great to work with Antonia, to learn about her creative process and how she approached the work, and also to see my research through the eyes of someone from such a different discipline and background. I find the combination of and collaboration between different subject areas in one project is really interesting, and it's been so much fun to work on. I really hope you enjoy the piece of music. Thank you.